Welcome to the digital product ordering and manufacturing demo of the Productive 4.0 project. This is Jaime Garcia Represa speaking from Luli University of Technology. This demo presents the work of Emmanuel Parn, Aparajita Tripathi and myself, researchers at LTU, joined together to showcase business negotiations, workflow execution support, and manufacturing operations in an Industry 4.0 use case. The demo has been set up at the Electronics Lab of Luli University of Technology. The demo consists of several software systems and 4 hardware components: a Fisher Technique factory used to model a production workstation of a smart factory, a PLC to send the electric signals for the actuators of the factory and read the electric signals from the sensors. The PLC also contains an OPC UA server inside. The third component is a computer to execute the software systems to deploy an Arrowhead local cloud. And finally, a Wi-Fi router to transmit the data between the PLC and the computer. For this demo, we have included all the Arrowhead systems inside the same local cloud for simplicity, but this is not required. Only those systems which have latency requirements for data transmission must be part of the same local cloud. In the left of the local cloud, we have the systems in charge of product ordering, a buyer and a seller that will perform a digital negotiation with the support of a contract proxy support core system. Each negotiation will agree on a number of products and manufacturing operations. The buyer and the seller do not need to be part of the same local cloud. They can be distributed as long as they have a contract proxy available in their local clouds. Once a successful negotiation has been reached between the parties, the contract listener will retrieve the orders and manufacturing can start. In the right side of the local cloud, we have the manufacturing systems. The negotiation orders will be uploaded to a smart product that will be introduced in the factory assembly line. In this assembly line, we have one workstation that can execute 2 operations, drilling or milling. When the smart product reaches the workstation, it will contact the workflow manager to perform the requested manufacturing operations negotiated. The workflow manager will in turn communicate with the workflow executor to perform a different workflow depending on the operations requested. The workflow executor consumes the services offered by the factory OPC server to execute a drilling or a milling operation and will send back the results to its workflow manager. The results are then propagated back to the smart product, and then the product will exit the workstation. The workflow executor and the OPC factory have latency requirements for its data transmission, so they must be part of the same local cloud. Likewise, the workflow executor is designed to work in coordination with the workflow manager that should be included in that same local cloud to meet communication requirements. To show the negotiation between a buyer and a seller, we have a graphical user interface. The interface includes options to manufacture different types of products, the quantity and the price for the total amount of the products. In this example, we will be the buyers and the sellers is a system with some store rules to accept only valid offers. We first tried to buy only one product, drill, and for €100. The seller did not accept our terms and made a counteroffer. We verify that we agree with the terms, and if accepted, then the negotiation terms are transformed into an order. The manufacturing of the order can now take place, but while we are buying things, we can also try to buy a mill product. The process this time is similar. We make a proposal and the seller will accept or make a counteroffer. Once we come to an agreement, the result of the negotiation will be manufactured. At any point after the negotiation has been finished and while the next one is taking place, the manufacturing systems can access the pending orders data. When manufacturing has to take place, the only thing needed to start the process is to introduce the product ID into the smart product system and physically add a piece into the model factory. Then the communication between the smart product, workflow systems, and PLC will take place automatically and the product will be manufactured. After the first product is finished, manufacturing of the second product can begin. This time, the product will be only milled.
I will only be needing.
We hope you enjoyed the demonstration of the digital product ordering and manufacturing demo. If you have any questions, you can contact any of us.